There are three kinds of special products you need to learn about in order to be able to factor later on. Special products are multiplication problems with polynomials that follow a specific shortcut or pattern. The first type of special product is called the square of a sum. The square of a sum is where you take a polynomial that's an addition problem and you square it. Okay? It'll either look like this, where you have the same addition polynomial multiplied by itself, or it could look like one addition polynomial that's being raised to a power of 2. Now, the special product of a square of a sum follows a specific pattern. If you think about our distributive property, we're always going to do a times a, which will give me an a squared. And we're going to do b times b, which will give me a b squared. So when I'm looking at my formula, there's always going to be an a squared and a b squared. But the other thing you need to notice is there's a middle term. The middle term is made up of these two terms, a times b and b times a, which is essentially a times b twice. And that's why our special product formula is a squared plus 2ab plus b squared. Now here's how you use these formulas. Okay? The first thing we need to do is recognize that this is the square of a sum problem, and I know that I'm going to use this pattern, a squared plus 2ab plus b squared. Now when it comes to looking at these polynomials, the very first term you have is called a. So when it says a squared, what we're doing is we're taking this term and squaring it. 2n times 2n is going to give me 4n squared. The second term in your polynomial is your b. So this 4 is our b. So when we do b squared over here, it's 4 times 4, which is 16. Now the middle term is where things get a little tricky. It's 2 times a times b. Well, if I do a times b right here, 2n times 4, that gives me an 8n, and then I just need to double it to get this middle term because I want 2 of these. Remember, there's one here and one here, so 2 of them is going to give me 16n. And so if I had used my distributive property, this is the answer I would have gotten. It's just that now I know a shortcut to help me find my answer. Let's try this one over here. Again, start with your formula. It's a squared plus 2ab plus b squared. The first term is your a, so a squared is going to be 5w times 5w, which is 25w squared. Your middle term is 2 times a times b. So remember, this is a, this is b. When I multiply those together as ab, I'm going to get 20w, and then I want 2 of those, which is 40w. And then finally, b squared, b times b, which is 4 times 4, is going to give me 16. So that's the square of a sum. And remember, if you look at your pattern, both of these signs are addition signs, which means in your answer, you're going to have 2 addition signs. Everything's positive in the square of a sum. Now the square of a difference is very similar. When you have the square of a difference, you have a difference or a subtraction problem that's being squared. And again, it'll either look like the same exact subtraction problem by itself or a subtraction problem raised to a power of 2. Now let's take a minute and try to figure out what this pattern would be. If I use my distributive property, again, a times a will give me a squared. I'm also going to have negative b times negative b, which will give me b squared. So that part of the formula is exactly the same. I have an a squared and a b squared. The middle is what becomes different. If I do a times negative b, that gives me this negative ab. And if I do negative b times a, that gives me this negative ab. So I have my a squared, I have negative 2ab, and a b squared. So that's my pattern for using the square of a difference. So it's a squared minus 2ab plus b squared. Okay, and remember, it's a plus b squared because it's negative b times negative b, which gives me a positive b squared. All right, so here we go. A squared. 6r times 6r gives me 36r squared. 2ab. 6 times 2 is going to give me 12r, 6r times 2. And then I'm going to double that, which is going to give me 24r. Now look, this is a subtraction sign here, which means this is a subtraction sign because it's really 6r times negative 2, which gives me that negative 12r there. So negative 12 times 2 is negative 24. I know it's going to be a subtraction sign because this right here tells me it's a subtraction sign. So if I want to just do my multiplication and not really think of the subtraction, that's okay, as long as I put subtraction in my answer. And then finally, my b squared, 2 times 2, that's going to be 4. And again, this is a positive, a plus, this becomes a positive. Let's try one last square of a difference. So I've got a squared minus 2ab plus b squared. So my a squared, 5 times 5, is going to give me 25, minus 2ab, so it's going to be a minus. 5 times y gives me 5y, times 2 gives me 10y. And then finally, b squared, y times y, is y squared. So that's our square of a difference. Now the last special product we have is called the product of a sum and a difference. This is where we take a polynomial that's an addition polynomial, multiply it by the same polynomial that's a subtraction polynomial. These are not going to be raised as a square because we are not multiplying the same thing by itself. So it's always two different, not two different, the same terms, but one addition, one subtraction. Now when we look at this pattern, this one is a little different. I have my a times a, which is my a squared. When I do my b, I'm going to get b times negative b, which is going to give me my negative b squared here. So this is the only special pattern that has a formula that has a negative b squared in it. Now here's where it's special, my middle term. If I do a times negative b, I get a negative ab. And if I do b times positive a, I get a positive ab. If I have one term that's positive and one term that's negative, it's always going to cancel out. So we're never going to have a middle term in these kinds of special products. My formula is just a squared minus b squared. So to find my answer, I take a squared, 3m times 3m is 9m squared. I take my b squared term, 5 times 5, which is 25, and I know it's going to be a negative because it's really 5 times negative 5, which is going to give me a negative b squared there. Okay, one last problem, a squared minus b squared. So my a squared, 4a times 4a is 16a squared. My b squared, 7b times 7b is 49b squared. And again, a squared minus b squared. So that's my final answer. And that's all three special products.